This is a video on the chi-squared goodness of fit test. The question states, in 1970, the Forest Service surveyed the Lake Tahoe Basin and determined that 60% of the land was in pristine condition, 20% was in good condition, 15% was in average condition, and 5% was in poor condition. The Forest Service has just surveyed 200 randomly selected acres of land to see if the land conditions have changed. So here's what they found. They found 100 acres in pristine condition, 45 in good condition, 35 in average condition, 20 in poor condition. So it's a little easier to create a table because we're going to do a chi-squared goodness of fit test because we want to see if the distribution of condition has changed. So I'm going to write down a table, and I'm going to write O for observed, and that's the 100, 45, 35, and 20. We're going to have E for expected, which we'll figure out in a bit. And we're going to be using the chi-squared goodness of fit test because we want to see if the data that we observe today fits the percentages or the distribution that happened in 1970. So our H naught is the land distribution is the same as it was in 1970. Whereas HA is the land distribution is not the same as it was in 1970. So to do this, we need to calculate the expecteds. Well, we had 60% is what we would expect to be in pristine condition. And we surveyed 200 acres. So to find the expected, we take 60% of the 200, which is 0.60 times 200, or 120. So there's 120 for the expected. Now we're going to do the same for the 45, the 35, and the 20. So for the good condition, that was expected to be 20%. So 20% of 200 is 0.2 times 200, which is 40. So our expected value for the good condition type is 40. So now let's look at the average condition, which is 15%. So I take 15% of 200, which is 0.15 times 200, which is 30. And that's my expected count for the average condition. And finally, for the poor condition, it was 5% expected. So 5% of 200 is 0.05 times 200, which is 10. So now I have my observed and expected table for this study. So now that I have the table, I can use a calculator. So let's go to the LibreText calculator that I programmed. So here's the calculator. We need to find a goodness of fit test on the calculator, and that's towards the bottom. So we'll see goodness of fit right here, and I click on that. And it says type in the values from the observed and expected sets separated by commas. We have an area for observed and an area for expected. So I typed the observed and expected in, and here's what we have: 100, 45, 35, 20 for the observed, 120, 40, 30, 10 for the expected. And I just hit calculate. That's all there is to it. Our chi-squared, that's how you read this. This is the Greek letter capital Chi. So chi-squared is 14.79, etc. And p for p-value is 0.002, etc. So now let's go back to the question and interpret what we've found. So here's the chi-squared at 14.79 and the p-value at 0.002 about. Let's draw a little picture of that. The chi-squared distribution has this shape, and our chi-squared value was 14.79, and it turns out that if you look at, say, 0.05 as a standard level of significance, then we're looking over here, and the chi-squared that corresponds to that is around 7.8. 14.79 is far to the right, or far into the rejection region. So that means I get to reject the null hypothesis and accept the alternative hypothesis. So let's write down our conclusion. And the conclusion is, there is statistically significant evidence to conclude that the land distribution today is not the same as it was in 1970. And I'm done with the problem. Thank you for watching this video.